everyone, and welcome back. Tonight, I want to take you into one of the most fascinating cosmic stories unfolding right now, a mystery that began quietly on a cold July night when astronomers in Chile spotted a faint object drifting across the sky. At first, it looked like nothing special, just another speck of light in a universe full of them. But within days, scientists realized they were witnessing something far more important. Something rare. Something we have only seen twice before, in all of human history. That object was later named 3I Atlas, and it is officially the third confirmed visitor from outside our solar system. Think about that for a moment. Out of the countless rocks, comets, and icy fragments that fill the darkness, only 3 have ever been proven to come from another star. And unlike the first 2, Oumuamua in 2017 and Borisov in 2019, this one did not just pass through quietly. From the very beginning, 3I Atlas behaved like an outlier. When the Atlas telescope first captured it on July 1st, researchers expected the usual pattern. A fast-moving interstellar traveler cutting through the solar system before disappearing forever. But 3I Atlas had other plans. As scientists studied its path, they realized its motion did not match anything they had modeled. It was not just moving through our system, it was moving with intention, gliding along the same flat orbital plane that the planets follow. For an interstellar object, this alignment is incredibly unlikely. It is as if it entered our solar system through the exact doorway we would expect, a long-distance visitor to choose a coincidence so precise that astronomers immediately took notice. And then came the second surprise, its massive size. Early measurements suggested that this object could be several kilometers wide, far larger and far heavier than anything we have ever seen come from another star. Instead of a fragile clump of ice or dust, this thing moved like a giant, a solid traveler built to survive unimaginable distances. So tonight, we are starting our journey exactly where scientists started theirs, with the moment of discovery. A find it on a telescope screen. A quiet entry into our solar system. And the first signs that this was not going to be an ordinary visitor. If you are ready, let us go deeper into the story of 3I Atlas and uncover why this cosmic traveler has captured the world's imagination. As astronomers began charting the motion of 3I Atlas, they expected to see the same pattern we have observed in every confirmed interstellar traveler so far, a steep, slanted path cutting into the solar system at an odd angle, like a stone skipping across water. These objects do not know or care about the structure of our planetary system. They simply appear, rush past the sun, and vanish into the dark again. But almost immediately, researchers noticed that 3I Atlas did not follow that pattern. Instead of slicing in at a random angle, its path was uncannily smooth, settling within the same thin disc-shaped plane where all our planets orbit. This region, known as the ecliptic, is essentially the flat table of our solar system, a narrow space where nearly all major bodies revolve around the sun. Interstellar objects, almost, never arrive neatly on this plane. In fact, statistically, the odds of an object from another star naturally entering along the ecliptic are extremely small. Yet 3I Atlas seemed to glide onto it with almost effortless precision. This unusual alignment raised the first major wave of scientific questions. Was it pure coincidence? A 1-in-a-million stroke of cosmic luck? Or did something about the object's past journey subtly steer it toward this perfect orientation? Even the more cautious researchers admitted that it was rare enough to merit attention. In models tracing Oumuamua and Borisov, both objects entered at sharp, awkward angles, exactly what we expect from visitors that formed around distant stars and drifted for countless years before arriving here. But Haromi, Atlas felt different. It behaved less like a lost traveler and more like something that knew the layout of the solar system long before it arrived. And this was not just a geometric curiosity. An interstellar object aligning so precisely with the ecliptic means it is suddenly far easier for telescopes to study, far easier for spacecraft to approach, and far more visible to us than it otherwise would have been. It is almost as if it arrived through the one orientation that gives Earth the clearest possible look. As astronomers continued plotting its trajectory, a sense of quiet unease grew. Because in science, when something aligns this perfectly, the question is not only how it happened, it is why now. When scientists finally calculated the approximate size of 3I, Atlas, the numbers did not feel real at first. Most interstellar objects we have seen, which, to be fair, is only a tiny handful, are relatively small and fragile. Oumuamua was barely hundreds of meters long. Borisov, though more comet-like, was still modest in scale. These are the types of travelers we expect. Lightweight wanderers pushed across galaxies by gravitational nudges and star-borne winds. 3I. Atlas did not fit that template. Based on its brightness, density, and the structure of its coma, astronomers estimated it could be several kilometers wide, large enough that many researchers began comparing it to the scale of a small city. And the mass, that was even more astonishing. Calculations suggested a total mass in the range of tens of billions of tons. Not millions, billions. This alone made it an outlier. For an interstellar object to survive the chaotic journey between star systems, it typically needs to be either small enough to drift gently or loosely bound enough to shed material over time. Something this big should have been broken apart eons ago, shattered by collisions or slowly eroded by cosmic dust. Yet 3I, Atlas, arrived in the solar system intact, stable, and moving with a kind of quiet confidence. This massive scale also explained another odd behavior. Despite releasing gas, dust, and vapor into space, it barely shifted at all. Normally, an outgassing comet behaves like a natural thruster. Every jet of gas nudges it slightly, altering its trajectory in measurable ways. But with something as heavy as 3I, Atlas, those tiny jets are simply not powerful enough to make a difference. It moves forward, almost like a freight ship gliding through calm water unbothered. Unshaken, steady. What surprised many astronomers was not just the size itself, but the implication behind that size. Objects this massive do not often wander. They tend to remain bound to the star systems they formed in. So, for something so large to be traveling through interstellar space, alone, evokes deeper questions. Where did it come from? How long has it been drifting? And what kinds of forces were powerful enough to launch such a giant across the galaxy? Whatever the answers are, 3I, Atlas, is not just a visitor, it is a survivor. A colossal traveler that has endured unthinkable distances, arriving in our corner of the cosmos as if its journey has only just begun. From the moment telescopes detected the faint halo around 3I, Atlas, astronomers knew they were dealing with something active. The object was not silent or dormant. It was venting gas consistently, visibly, and in substantial amounts. On paper, that should have made it behave like any other comet we have ever studied. Comets are famous for their unpredictability. When sunlight warms their surfaces, jets of gas erupt, pushing them around like tiny, natural rocket engines. Their paths wobble, drift, and constantly require recalculation. But 3I, Atlas challenged that rule from the very beginning. Despite releasing plumes of gas strong enough to be detected across vast distances, the object's motion stayed astonishingly steady. Observatories around the world recorded thousands of positional measurements, looking for the faintest hint of a wobble, any sign that its jets were pushing it off its predicted orbit. Yet every analysis returned the same result: no measurable non-gravitational acceleration. The object was not drifting. It was not being nudged. It was not reacting to its own outgassing at all. This level of stability is not just unusual, it is almost unheard of. Even small, gentle jets should have produced at least some deviation. But 3I Atlas moved as if nothing was touching it, as if the streams of gas streaming from its surface had no physical effect whatsoever. To many researchers, this implied one thing: the object must be incredibly massive, so massive that the gas it released simply lacked the force to alter its course. Still, the puzzle went deeper than that. Most comets rotate or tumble as they outgas, creating uneven thrust and unpredictable shifts. But 3I Atlas appeared to have a kind of internal balance, venting consistently without producing visible spin or instability. It behaved less like a fragile ball of ice and more like a perfectly weighted stone, gliding through space with silent precision. Some scientists suggested exotic explanations: unusual density, an internal structure we do not yet understand, or a composition that naturally resists torque. Others simply admitted that nothing in our comet models fully accounts for the level of calm displayed by this object. In a universe where motion is rarely simple, 3I Atlas has managed to move with serene perfection, refusing to behave like anything we thought we knew. As researchers turned powerful spectrographs toward 3I Atlas, expecting to decode a familiar chemical signature, what they found instead pushed the mystery into even stranger territory. Most comets, whether from our solar system or interstellar space, release a predictable blend of water vapor, dust, organic compounds, and trace metals. Among those metals, nickel and iron almost always appear together. They form under similar conditions, bond in similar ways, and are found in roughly equal proportions in nearly every comet ever studied. But 3I Atlas broke that pattern completely. Its emissions showed strong, unmistakable signatures of carbon dioxide, along with traces of cyanide, and most surprisingly, a noticeable presence of nickel vapor. Yet the one element scientists expected to see alongside nickel was nowhere to be found. There was virtually no iron at all. This imbalance was not subtle. It was dramatic, and it did not match any known natural process. To understand why this is such a problem, imagine examining rock samples from dozens of mountains around the world. In every one, you find granite paired with quartz. Then suddenly, you find a mountain containing only granite, perfectly separated with the quartz inexplicably missing. You would immediately ask, what force could have filtered or removed something so fundamental? That is the question astronomers now faced. Some researchers proposed that 3I Atlas might come from a very unusual star system, perhaps one where the original environment favored nickel-rich materials and suppressed iron formation. Others suggested extreme heat, cosmic irradiation, or oxidation could have stripped away iron long before the object arrived here. But each scenario had gaps. No known stellar nursery routinely produces such pure, isolated nickel vapor. The strangest part came from the way the nickel was being released. The vapor did not appear chaotic or random. It emerged in controlled-looking bursts, forming patterns more consistent than those of most natural comets. Even conservative scientists admitted the chemistry looked organized in a way that challenged typical models. Importantly, Mainstream researchers avoided jumping to conclusions about advanced processes, but they also acknowledged this. If the chemistry of 3I Atlas is natural, it represents a kind of cometary behavior we have never observed before. In short, the chemical fingerprint of 3I Atlas is not just unusual, it is unprecedented, hinting that this object may hold secrets about planetary formation, cosmic chemistry, or even ancient environments that do not exist anywhere near our Sun. As astronomers examined the spectral data from 3I Atlas more closely, they began noticing something even more unusual than the absence of iron. The nickel vapor being released did not behave like the metallic gases seen in ordinary comet tails. Instead, it showed signs of forming complex molecular structures that hinted at a very specific pattern, one that, on Earth, is only associated with refined compounds produced in controlled environments. The compound that drew the most attention was nickel tetracarbonyl. To anyone outside of chemistry, that name might sound abstract, but its significance is enormous. On our planet, nickel tetracarbonyl is a synthetic gas created during industrial metal purification. It forms only under very narrow conditions, low temperatures, specific chemical ratios, and the presence of carbon monoxide. It does not appear naturally in the Earth's crust, oceans, volcanoes, or atmosphere. So when astronomers saw spectral lines that resembled this compound, they were understandably cautious. No one claimed the object was made of industrial materials. No one jumped to conclusions. But the fact remained, the emissions from 3I Atlas looked oddly similar to something we normally associate with engineered processes. The balance of nickel to carbon-bearing molecules was too clean, too selective, and too consistent over time. This did not prove anything extraordinary, but it posed a question that natural explanations struggled to answer. To maintain a gas like nickel tetracarbonyl near the Sun is difficult. The compound is fragile. It breaks down quickly under heat or intense radiation. Yet 3I Atlas seemed to emit nickel-rich vapor steadily, without the instability we would expect from a delicate molecule being blasted by solar energy. Some researchers suggested the object might carry exotic carbon chemistry, born in environments unlike anything in our solar system, perhaps near a carbon-rich star or from the remains of an ancient planetary core. Others proposed it could be undergoing ongoing chemical reactions deep beneath its surface, processing metals in a way that mimics industrial refining without involving intelligence at all. Still, a quiet question lingered. Why would an interstellar object naturally produce something so similar to a refined alloy gas? Even the most cautious scientists agreed. Whatever process is happening inside 3I Atlas is unlike anything we have seen, and understanding it could teach us entirely new chemistry that exists far beyond the boundaries of our familiar solar system. One of the most startling discoveries about 3I Atlas came from something so simple and so visually obvious that, once identified, it changed the entire conversation. Its tail was pointing the wrong way. In every comet humans have ever observed, from ancient records to modern telescopes, the Sun pushes ionized gas outward, creating a tail that always streams away from the Sun. This behavior is so universal that you could almost use a comet's tail as a compass. Where the tail points, the Sun is in the opposite direction. But 3I Atlas broke that rule completely. High-resolution studies revealed that the object was emitting a constant jet of gas directly toward the Sun, not sideways, not angled, not swirling in chaotic arcs, simply and consistently sunward. And this was not a faint, intermittent puff. It was a structured, measurable plume containing carbon dioxide, cyanide, and traces of nickel vapor. Under normal physics, this should not happen. If solar radiation is strong enough to push ordinary cometary gas outward, then how is 3I, Atlas, releasing material into that radiation? Why is not the solar wind overpowering it? And more importantly, why does the object remain perfectly stable while doing something that should destabilize it? A comet emitting a sunward jet should behave like a tiny spacecraft firing a thruster. It should be pushed backward, its orbit shifting in measurable ways. Yet, with 3I, Atlas, the trajectory remains precise, unmoved, undisturbed. Scientists quickly scrambled for explanations. Some suggested asymmetric heating. Perhaps the object has a region that warms much faster, funneling gas inward. Others proposed magnetic guidance, with charged particles streaming along invisible field lines. But both ideas struggled to explain the same issue: the consistency. The plume does not flicker with rotation. It does not change intensity as distance to the sun varies. It acts like a controlled process, steady and purposeful, instead of a chaotic natural vent. Even cautious astronomers admitted the behavior looked aligned, directed, or highly organized. Not artificial, just unusually precise. And so the sunward jet became one of the strongest indicators that 3I, Atlas, is not just chemically unique, but physically disciplined, guided by forces or internal structures we do not yet understand. In a universe where comets behave like drifting snowballs, 3I Atlas moves like something that refuses to follow the rules we thought were absolute. As astronomers continued tracking 3I Atlas across the sky, the object kept surprising them. First came the odd alignment, then the impossible stability, then the backward-facing plume. But the most dramatic twist emerged only when observatories around the world began comparing their updated orbital models. Something did not add up. Interstellar objects are fast, so fast that the sun's gravity cannot hold them. Their paths are open curves, designed by physics to swing once around the sun and disappear forever. That is how Oumuamua behaved. That is how Borisov behaved. And that is what everyone expected from 3I Atlas, at least at first. But new calculations suggested a quiet, subtle, but unmistakable trend. 3I Atlas appeared to be slowing down. Not dramatically, not suddenly, but just enough to raise eyebrows. Because even a small deceleration, if it occurs at the right moment in an object's path, can change everything. The timing of this slowdown was especially curious. As 3I Atlas approached its closest point to the sun, the moment when gravitational interactions become the most intense, its speed began dipping below predicted values. If this trend continues, the object may cross what astronomers call the escape threshold. And if that happens, the sun's gravity could do something unprecedented: capture an interstellar visitor. This possibility is rare, theoretical, and incredibly difficult to confirm. In hundreds of millions of years of solar system evolution, scientists believe only a handful of interstellar objects might have ever been captured, and none have been directly observed doing so in real time. So if 3I Atlas were to become gravitationally bound, even temporarily, it would be the first such event recorded in human history. Naturally, researchers rushed to propose explanations. Some suggested that the unusual gas emissions may be interacting with solar radiation in ways we do not fully understand, creating a kind of drag. Others argued that the plume's direction pointed sunward could be producing subtle effects similar to tiny braking forces. But none of these ideas fully explain the precision of the slowdown or why it coincides so neatly with the object's solar approach. For now, the astronomical community is split. Is this a groundbreaking natural event? A coincidence of timing and chemistry? Or is 3I Atlas following a path too perfectly shaped to be accidental? What everyone agrees on is this: if the sun truly captures this visitor from another star, it will rewrite what we thought we knew about interstellar physics. And the mystery of 3I Atlas will deepen even further. As excitement around 3I Atlas grew, the world waited for one thing above all: a clear picture. Not artist impressions, not blurry telescope silhouettes. A real, high-resolution image of the most mysterious interstellar object ever discovered. And according to official statements, such images do exist. NASA's Mars Reconnaissance Orbiter, one of the most powerful imaging platforms humanity has ever placed in space, passed within observational range earlier this October and captured detailed photographs of 3I Atlas from roughly 2 million miles away. And then, nothing. Days passed. Then weeks. The expected release never came. No raw files. No previews. Not even a single low-resolution frame. Instead, NASA issued a short explanation. The images were undergoing processing, quality checks, and necessary calibration. Under normal circumstances, that would sound reasonable. Space imagery often requires careful handling to avoid misinterpretation. But this time, the silence felt different. Scientists outside NASA began voicing their frustration. These were not classified military pictures. They were historic observations of a unique interstellar object, captured using publicly funded instruments. Researchers emphasized that even preliminary or imperfect data would be invaluable for ongoing analysis. Instead, nothing was shared. Not even a timeline. Meanwhile, online communities exploded with speculation. Some believed the delay was bureaucratic. Others suspected the images showed something unexpected, perhaps geometric patterns, unusual reflections, or simply a structure too unfamiliar for quick public release. Most of these theories were imaginative leaps, built more on curiosity than evidence. But the lack of transparency did not help calm the discussion. Even seasoned astronomers admitted the delay was odd. Historically, NASA has been relatively open, often releasing images, even unprocessed ones, within days. In contrast, withholding the clearest view of a once-in-a-lifetime object only amplified public questions. Of course, there are practical explanations. Processing backlogs, staffing shortages, a desire to avoid misreading early data, the need to verify unusual details before making them public. All valid possibilities. But until the images appear, people will continue to wonder what those photographs actually contain. And so, the mystery deepens, not just because of what 3I Atlas is, but because of what we still have not been allowed to see. The most detailed look humanity has ever had at an interstellar visitor may already exist, stored quietly on a NASA server, waiting for someone to decide the world is finally ready. As the evidence grew stranger and the unanswered questions piled up, the scientific community found itself split into 3 camps, each proposing a very different story for what 3I Atlas truly is. None of these theories are perfect, and all of them face challenges, but together, they outline the 3 most realistic possibilities we have right now. The first is the exotic but natural comet explanation. According to this view, 3I Atlas is simply a rare type of object from a chemically unusual star system, Perhaps one rich in carbon compounds, or shaped by conditions we have never seen nearby. This would explain the unexpected nickel dominance, the lack of iron, and some of the strange behavior. Supporters of this theory argue that the universe is vast, and our sample size of interstellar objects is tiny. Maybe this is just the first of many new categories we will discover. But even they admit that the sunward plume, the stability, and the potential deceleration are hard to fit into standard models. The second theory paints a more ancient picture. It suggests that 3I Atlas might be a pre-solar relic, an object older than our Sun, formed in a star system that collapsed billions of years ago. This idea explains the heavy metal content and the possible filtering of iron through extreme cosmic processes over immense time. In this scenario, 3I Atlas is a messenger from the deep past, carrying with it chemistry shaped long before Earth existed. It would be extraordinary, but still natural. A geological time capsule drifting through the galaxy. And then there is the third theory, the most controversial, but also impossible to ignore given the data we have, the technological artifact hypothesis. This idea does not claim the object is an active spacecraft. Instead, it proposes that 3I Atlas could be a fragment, a shell, or a long-dead remnant of engineered material from a civilization that no longer exists. In this view, the precise alignment, the stable motion, the unusual chemistry, and the controlled-looking plume are all pieces of an ancient mechanism behaving in ways we do not yet understand. Most scientists remain cautious. They emphasize that extraordinary claims require extraordinary evidence, and we do not have that yet. But they also acknowledge that dismissing any possibility before the data is complete would be unscientific. For now, all three theories remain on the table. And until we see those high-resolution images, until we finally look the object in the face, the true identity of 3I Atlas remains one of the biggest cosmic questions of our time. As we step back from the details, the chemistry, the strange plume, the improbable trajectory, the silence surrounding the unreleased images, one thing becomes clear. 3I Atlas is not just an astronomical object. It is a reminder of how little we truly understand about the universe. Every time we think we have mapped the rules, something arrives from the deep darkness to show us that the cosmos still holds surprises capable of reshaping our perspective. Maybe 3I Atlas is a natural wanderer, sculpted by conditions that simply do not exist in our own solar system. Maybe it is a relic from a time so ancient that even our oldest rocks feel young by comparison. Or maybe, just maybe, it carries the fingerprints of technology so old or so unfamiliar that we no longer have the context to recognize it. None of these possibilities are confirmed, but each one reflects a different way of understanding our place in the galaxy. What makes this story meaningful is not just the mystery itself, but the way it reveals the limits of our certainty. Even with modern telescopes, advanced sensors, and decades of study, an object from another star can still arrive and quietly remind us that knowledge is not a destination. It is a journey filled with questions that stretch our imagination, challenge our assumptions, and encourage us to remain curious. Perhaps the greatest lesson 3I Atlas offers is not hidden in its chemistry or its trajectory, but in the reminder that science is most alive when faced with the unknown. It encourages us not to fear uncertainty, but to follow it, to ask better questions, to explore patiently, to let wonderfulness be part of our daily vocabulary. So wherever this story leads, whether the object escapes the sun, falls into orbit, or reveals something unexpected, when the long-awaited images finally appear, one truth remains: Mysteries like this are not obstacles. They are invitations. They call us to look deeper, think wider, and stay open to possibilities beyond the borders of what we know. Thank you so much for joining me on this journey tonight. If this cosmic mystery ignited your curiosity even a little, feel free to share your thoughts, your theories, or even your wildest interpretations. And if you would like to follow the next chapter as soon as it unfolds, make sure to stay tuned for more stories from the strange, the ancient, and the unexplained. Until next time, stay curious, stay thoughtful, and keep looking up.